Right, okay, have a look at that sequence and tell me what the next term in the sequence would be. And why? Why? Okay. One term to the next. So there is a multiplier here. You are multiplying something to go from one term to the next. Therefore, it is a geometric sequence. Okay. So with an arithmetic sequence, it's going up by the same amount each time. But with a geometric sequence, it's being multiplied by something. Are you happy so far? Okay. So sometimes the question will come like this. Yes. Come and get one off my desk. Sometimes you will get a question like this, and it will say, find the first terms of the sequence u, little n, equals 1 over n. What that means is, you are looking for a sequence, you start with the number 1. Okay? So, if n is 1, then 1 divided by 1 is 1. You start with the next number, which is 2. 1 divided by 2 is 0.5 or a half. And the next one. What's the next? I didn't say this was a geometric sequence. I said a third and a quarter. Okay? First 4 terms of the sequence are now written on the screen. Okay, are you happy so far? So, we've covered finding terms of a sequence when it looks a little bit different to what you are used to. We've covered geometric sequences. This is the biggie, if you like. I would like you to look at that sequence and tell me if you can find the rule for that sequence. You can discuss with me. Well, yeah, you can discuss openly, it's fine. Yes. I am squaring it each time. So, what would you say the rule was for that sequence?
N squared.
Brilliant. The rule for that sequence is n squared. Take the first term, when n is 1, 1 squared is. Next term, when n is 2, 2 squared is. Next term, when n is 3. And so on. Are you happy with that one?
Yes.
Okay. Yes.
That's wonky.
Do you want to just move it slightly so it's not? What about that sequence? Any clues on that sequence? I love it, but well done, you were really quick with that. Why is it n squared plus 1?
Because 1 squared, which is the first term, is 1, and plus 1 equals 2.
Okay.
Then second 2 times term is 4 plus 1.
So what you spotted was that if you had the sequence for n squared, then each number in this sequence was 1 more each time. Okay? Just have a little look at something else. What does this sequence go up in? From 2 to 5? From 5 to 10? From 10 to 7? From 17 to 26? And from 26 to 37? Okay. Oh, why have I written 37? It's because I'm looking at somebody who's not focusing. And then 11. What do you notice about that?
They all go up in 2.
Brilliant, they all go up in 2s. So if you like, my second difference is 2. Half of 2 is?
1.
And it's n squared. It's 1n squared. Happy with that so far?
Yes.
Okay. So, what about this one? What does it go up in? Well, can anybody spot a rule for that first of all?
N. Wait. No. N squared plus 2. No.
No.
Is it 5n plus 1?
Okay, what does it go up in? What does 6 to 11 go up in?
5.
What about 11 to 18?
17. 7.
What? And then 9 and then 11. So when you can see that it's going up consistently, you can find your second difference, which is 2. So whatever your second difference is, you half that, and that's your coefficient of n squared. So half of 2 is 1, so I know that my sequence is going to have an n squared in it. Happy with that? I'm going to write n squared. So I'm going to write above the first few terms of n squared. So what have I done to go from 1 to 6?
5.
I've added 5. What have I done to go from 4 to 11?
7.
What have I done to go from 9 to 18?
9.
What have I done to go from 16 to 27? And from 25 to 38?
13.
What do you notice about that set of numbers?
Bottom.
They are. Can you find a rule for that set of numbers?
And
You add 2.
Well, you're looking at 5, 7, 9, 11, 13. Don't think too deeply. What's the rule for that?
and plus 2.
So it's going up in 2s, so it's 2n plus 3. So my rule for this sequence 6, 11, 18, 27, 38 is n squared plus 2n plus 3. Does that make sense to you?
Yes.
Okay, so we will do another one. So what we've done there is we found the difference between each of the terms in the sequence. We found the second difference, which has come out as 2. So we half that coefficient. That gives us 1, so we know n squared. We then write the sequence of n squared, and we look at what is happening to go from n squared to the sequence that we've got, and we write that down as its own separate sequence and find the rule for that sequence. And then we put it all together, so that is n squared plus 2n plus 3. Okay? So, let's have a look at this one. So, from 4 to 13, I've gone up by... You do it in a minute. From 13 to 26, I've gone up by...
13.
From 26 to 43...
17.
And from 43 to 64. Okay, so can we find the second difference? What's the second difference? Okay, can you all see it's gone up by 4?
Yes.
So how many n squared?
2.
Brilliant, 2n squared. So what I suggest you do is right above, I would firstly say 1, 4, 9, 16, 25. And then double it for 2n squared. So 2, 8, 18, 32, and 50. Are you happy with that? Yes? Okay, what have I done to go from 2 to 4? To go from 8 to 13? To go from 18 to 26?
8.
To go from 32 to 43?
11.
And to go from 50 to 64?
14.
Okay, now I've created a little sequence there. What's the nth term rule for that little sequence? 3n minus 1. So I can write here plus 3n minus 1. Are you happy? Just give me a hands up who is happy and thinks that they could do that. Yeah? Okay, fantastic. I'm going to give you some to do then. Do you want to stop? You just press the red button.